Good afternoon, everybody. Thanks for having me here. You already got a little bit of a taste of the Volute in the presentation before this by United Utilities. I'm going to tell you about a new Volute, the Volute Duo. And what this technology allows us or enables us to do is to offer you the same benefits that we already do with screw press technology, but we can widen the application range and we can reduce the amount of wearables for this. So what I will tell you is I will give you a short introduction of the company AMCON, where we're coming from, where we started, where we're going. Then, though some of you already had this short introduction into screw press technology by United Utilities, I will give you a quick rundown on how it functions, especially so I can then tell you what is different with this new technology and how that functions. I'm a service team manager at AMCON. My team is responsible for pilot testing, commissioning, R&D testing, technical support. So in that sense, we do a lot of testing, or my team has done a lot of testing with this technology. And I think it's very interesting for you to see a couple of the results of these pilot tests to give you an impression of the scope of wastewaters we can treat with this thing. And then at the end, I will wrap up with a very brief conclusion, generalization of what you can expect. So, AMCON was founded roughly 30 years ago by Mr. Sasaki. He was working as an operator in a wastewater treatment plant. He saw screw press technology. He saw it didn't work. It kept on clogging. It needed a lot of water. So he came up with the moving ring principle. That's what AMCON started like in '74. Ever since, the screw press technology has remained at the core of what we do. We made some ventures into sludge drying, into polymer preparation systems and the like, but the screw press technology is and remains at the core of our company. I put a couple of iterations, so to say, on that we had. On our website, you can find many, many more. It's like a museum. For the keen observer, you can already see in 2004 we were doing something with 2 screws inside for very particular applications. Then the principle of operation. Screw press technology works by conveying solids through a cylinder. And so you get flocculated sludge coming in on one end, you have the dry cake coming out on the other hand, and the screw conveying these from one end to the other. And in the meantime, of course, you have the filtrate coming out just under gravity and under pressure that we generate. The difference with traditional or classical screw press technology is that we don't use a filter mesh around this cylinder, because the filter mesh keeps on clogging and you need to keep it clean. What we have is a self-cleaning filter mesh. We make this filter mesh by stacking fixed rings and moving rings on top of each other, with a spacer in the middle, of course. And the screw agitates these moving rings, and you can imagine that then the filter gap is constantly moving against each other, which keeps the filter mesh clean. So it's very, very stable. It's a very unspectacular technology if you from an engineering perspective, but the results are fantastic and very reliable, high reliable in operation. The benefits might be already obvious. Like whereas a centrifuge, and for your information, we typically compete with centrifuges and the belt presses, which perform very similar functions with similar results. But the benefits of the screw press technology is that we have a much, much lower energy consumption. You can imagine that if you use energy to convey this a couple % of solids in the wastewater and to compress them, it takes much less energy as if you would have to use energy to spin this whole bulk of wastewater around at a couple thousand RPM. So that's the first and very obvious benefit. And as you could see already in the long-term pilot test that United Utilities did at the Davy home site, this can go up to 84%, though I know sites where we were able to save up to 95%. Because we have the self-cleaning moving ring technology, we can do this without much water compared to some technologies, belt presses that use a lot of washing water. We can save really up to 99% in extreme cases. Further, our technology works at roughly 0.5 to typically, 7 RPM. So it wears down slow, it breaks. If it breaks very slow. Maintenance is very plannable. You see it thousands of hours in advance when something is necessary. It also means that it doesn't break spectacularly. In all my time in my current role, I've seen it once that a machine of us broke down to such an extent that we couldn't keep running the machine. That means that the operational reliability is extremely high. It also means that this thing can run without an operator 24/7. I don't know if it's the official maintenance recommendation that we give, but it's like, look at the machine for 5 minutes a day, and that's it. So last year I was in our most remote installation, which was in the utmost part of Finland, where one of our volutes has been running now for 13 years without any noticeable service. A bit of an extreme case, of course, but because you can extend the operation hours, because you don't need an operator to constantly keep looking at it, you can also downsize the machine that you need. Good to know for the operators as well, low RPM is low vibrations and very low noise. I would almost dare to say that if we would have the biggest machine that we have, and we would have it here in the place of Job, we would actually still be able to do this presentation without a microphone. It's really incredible to have this low level of noise. But I'm an engineer, so I can also admit to you that screw press technology is not for everyone. It's not for every wastewater. And screw press technology typically suffers when you have a high fiber or high or inorganic content in the sludge. And there's not really a fixed limit, but I would say that from 20% fibers or 40% inorganics, we need to start thinking, do we need to adjust our cylinders, or can we go still like this? It doesn't mean that you need to adjust, but you should start thinking about it. And the higher these numbers are, the more adjustments are necessary. And we have units that run on 70% inorganics. It is possible. The problem or the challenge is that these adjustments typically eat away on the benefits that I just mentioned. So, and of course, at some point you have a economical or a practical level where we just say, very sorry, but this is just not something for screw press technology. The way how these things actually are a problem for screw press technology is that they block the cylinder. What inorganics typically do is that they increase the pressure because inside the cylinder, and they wedge themselves in between the stationary parts and the screw. The same thing with the fibers, and there is an interplay between these two. So what you here see, this is what happens if a machine blocks, and if the sludge sticks to the screw and just starts to co-rotate, there's nothing going through, so you don't have any throughput. And the only basically solution for this is that you take the screw out, clean it, put the screw back, which is something we don't want to do. So AMCON, we call ourselves the screw press specialist. We get a lot of the technically difficult wastewaters sent to us, and we noticed that for some customers, we unfortunately we had to say no. We couldn't do their wastewater until now, because what we have is the Volute Duo. This offers the same benefits as we had before, but we can now also apply this on these difficult wastewaters. And the difference between the single screw and the double screw technology is obviously that we have two screws. We have two screws in one cylinder, and the screws of these flights actually turn into each other, meaning there's no space for any blockage to happen, or if it happens, it's simply pushed out. The second difference is that we have an externally driven moving rings. If you remember, I told you that these moving rings are basically pushed up and down by the screw, by the flights of the screw. With this new technology, we have a separate motor for that. And this helps in a couple of ways. You don't have the screw to ring contact, so it also reduces the wearables, but it also helps to prevent the blocking because there is no, the solids cannot wedge themselves in between the space of the screw and the moving ring. And then the third thing is the double cutting. It's a bit of a difficult to explain, but basically the pattern in which the rings are moving, on the one hand gives the cake something to grab on so you can push it, you can exert some pressure, and on the other hand, they keep cutting into the cake, which allows more area where you can actually draw the filtrate out. And here you see just a cross-section of the Volute Single and the Volute Duo. So you see the two screws running into, or like in between each other, with the externally driven moving rings. All right, so I want to present you with 5 sort of exemplary sludges. It's definitely not an exhaustive list of what we now can do with this technology. And it's the number of tests that I can present to you is too small, and the tests are not super comparable to each other because they're all the complex wastewaters that I can give you nice averages or nice graphs. I can give you the screenshots from the pilot test reports to give you an idea of what is possible. The first one we did in Czech Republic, where we are located with our office. It's a chemically precipitated sludge, inorganic content between 80 and 90%. And as I said, we actually had a normal volute running on this sludge, but we had to adjust it with special moving rings, different motor, and we couldn't exert the pressure on the sludge to get a nice dry cake. We went in with the Duo, and it actually worked fantastic. It's just something, when you know you cannot block the cylinder, you can really push the machine to its limits in order to try to get the driest cake. Slight side note on this one, we couldn't actually totally push the machine because the customer had a very strict phosphorus limit in the filtrate. So 3 ppm was the limit, so we had to limit the pressure we wanted to put on the sludge. And for your information, all the pilot tests were done with an RVP 241, which is our smallest model for this technology. Throughput ranges from 10 to 50 kilos per hour. And you see here the dryness and the throughput mentioned. To give you an idea, pilot testing, you try to optimize for different scenarios, so maximum dryness and the best overall. Excellent capture rate as well, but it was also necessary because of this phosphorus removal. The second one is actually when my guys brought back the cake, I thought they were playing a trick on me. It's from a plastic recycling plant. They shred this agricultural plastic. They have a duff, and then this sludge went to our machine. The stuff that comes out of this is so rock solid hard. It's not necessarily super dry, but somehow the interplay between some soil, some sand, and some plastic really makes this into a brick. The whole factory, it was actually quite difficult to test because the whole factory that they made for this is struggling with this particular sludge. The fibers somehow wedge themselves into any space between a moving object and a stationary object. So, for instance, impeller pumps, it takes them 5 minutes to block. Our standard volute, it took them 2 minutes to block, and there was no way that could ever work on this sludge. But with the RVP, absolutely no problem. So here as well, minimum flow and a maximum flow. As I said, the number of test runs we could do on this was rather limited because the sludge supply was a bit of a challenge. The third one was from Sweden. And what you see here is that it's not so much the limit, like the total amount of inorganics and fibers that's a problem. Because if you look at this, like 11% inorganic, 29% fibers, it's not something that you would be super careful with if you read this on a screen. But somehow this plant, it was a paper mill, or it was actually a factory that was making the paper pulp for the paper mills. They had at least 5 technology providers on site, and none of them achieved any measurable cake. Every machine would just clog up super fast. Again, the RVP managed, and the stuff that comes out here is really like, it's this soft board. If you put soft board in a glass of water overnight, that's the cake that came out here. And you also see the capture rate of 99 to 100%, which was incredibly nice. Added advantage for this customer is that we tried, they had a DUF and a belt press. Belt press was using 50% of its throughput as heated, pressurized washing water to keep the belt from unclogging. And we used no washing water whatsoever, 0. And moreover, we could actually work with the sludge that was going into their DUF. So they could replace the DUF and the belt press by a single technology that uses less water and less energy. Here again, some numbers. I think the slides will be shared later, so you can have a look. I think this is especially relevant. I hear a lot about digested sludge on this conference, logically. This was a mix of digestate and SAS, or VAS, as we call it in Czech Republic. Again, not too crazy content, but very big fibers, because there was also, they were using the process water was going there. Also, the stuff that they were cleaning the cars that brought in the cattle to be slaughtered. So a lot of big particles. Again, no problem whatsoever. The existing volute on this side, again, it is possible, but it had to run without any pressure of the sludge. So the dryness was just, I don't know, it was like 10, 12% that we could achieve there without blocking the machine. With this, you can actually squeeze it and achieve much higher values. Then the last one, a meat rendering plant. Probably the nastiest smelling place I've ever been to. They shred cows and horses here, and it's in Sweden, so they go in as one block of ice. It's really interesting sight to see. Very sticky sludge, and I think this is also a nice benefit that we as AMCON can provide. This customer got a very sudden legislative pressure, let's say, to do something about their wastewater. We got this machine there within a week, and they rented it for a couple months before they could solve the wastewater problems. And it's something that we quite typically do. So it's not too difficult sludge, except for that it was very sticky, but we managed to work with this without any problems. It's getting a bit repetitive, I'm sorry, but it's just we don't have any problems with this technology so far. So this is my conclusion. I may be a bit too much of a specialist and a perfectionist to be able to give you nice, general, glossy summaries. But I think that in general, overall speaking, we can say that the difference between a single screw and a twin screw, there are basically 3 scenarios. The first one is that they both perform at the same rate without any problems, and then it's really up to the customer which technology fits better to their needs in terms of investment and the sludge requirements. The second scenario is very clear. Sometimes screw press technology or standard screw press technology just doesn't work, and you have one option you can go for a screw press of the Volute Duo type. And this is exactly the thing that I mentioned. We can now extend our range of application to these complex wastewaters. And the third scenario is when the standard technology actually outperforms, or the other way around, and then it's really just do a test and you know which one fits your needs the best. So as a conclusion, we can offer now the same benefits that the screw press offers in a wider application range. We're insensitive to fibers and inorganics. And a further benefit is this, that because we have no contact between screw and rings, we actually reduce the amount of variables significantly. So that was all I wanted to say. I wanted to thank Evergreen Water Solutions. They're here. They did a tremendous job together with United Utilities and their long-term pilot testing. They're downstairs. Visit them. They have a Volute cylinder lying there. They can explain you everything. They have brochures, and we're more than happy to talk to you there further on the details. But for now, thanks. If there's any questions.
Okay, thank you, Robert. Time for any questions, if anybody has any. Can somebody take that gentleman a microphone, please?
Yeah.
No. You're going to get one.
Right, okay, apologies. 100% capture rate, that's quite a statement to make. I've never seen any technology deliver a 100% capture rate. And I've been around and I've monitored your trials that you've done in the past with Volute, and I've never seen 100% capture rate. Is that specific to the Duo? And, sorry, I'll ask the next question as well. Have you got a Duo in the UK that we can trial very quickly?
On the first question, no, that's not specific to Duo in the sense that on a normal Volute, we wouldn't be able to run this sludge. So I think it's specific to the sludge, and this sludge can only be treated if you want to have screw press technology. Well, this sludge can only be used with a Volute Duo. So in that sense, sort of indirectly, yes, it's related to the to this particular technology. And on the second one, Evergreen is your man to go to, and we can supply quick activities and quick machines. Yes. At the moment, I don't think so. Or no, at the moment not. But it takes 2 days to ship it here, right?
Okay, thank you. Any more? Oh.
Sorry, Leah Abdu, Atkins. In the third scenario you showed there, you advised that the normal Volute in certain scenarios was better than the Duo. What could you explain what scenario that was? I meant it's either the one outperforming the other. It was a bit complex to get it in one picture, but so there are scenarios where one technology outperforms the other, and to be honest, I'm not sure what kind of mechanism is behind this. So I'm not sure why the one or the other would be significantly better. It's always a small difference, it's a couple percent, but we tend to see that that this is there. But for now, I need to say that I don't know.
Okay, time for one more, if anybody would like to ask one. No? Okay, then thank you, Robert. Thank you very much. So, next up,